Hello everyone. Today I'm back with another Leetcode practice video. And today the problem that I will be going over is best time to buy and sell stock. So this is an easy problem. It is listed under the sliding window problems, so that gives us a hint as to that tells us pretty directly what type of approach we would need in order to solve this problem. So let's make this quick. The problem goes as follows. You are given an integer array prices where prices of I is the price of Leetcoin on the ith day. You may choose one single day to buy one Leetcoin and choose a different day in the future to sell it. You return the maximum profit you can achieve. You may choose to not make any transactions, in which case the profit would be 0. So before I do anything, I would like to take notes. What is the input? What is the output? And what other context and other information do I get from this problem that helps me solve it? The input is an int array called prices. The index is index I is referring to the date. For the output, we want to return one int, which is just the maximum profit that we can achieve. Okay, now let's take a look at the context, the constraints, any conditions that could help guide our problem solving. For this problem, we can only choose one day to purchase and one day to sell. We can only sell one stock of Leetcoin. Next, we can choose to make no transactions, which tells us that the max profit will always be greater than or equal to 0. And next, let's look at the constraints. So there will always be 1 to 100 days in prices. So we can't have an edge case where there are 0 days somehow. And finally, all prices will be non-negative numbers, specifically between 0 to 100. So there is one edge case that comes to mind when looking at these constraints, and that is what happens when there's one day. I think at this point we just return 0. There's no point in doing anything with this because there's only one day. We can't purchase and sell on the same date. So now let's get into solving the problem. We know that it's a sliding window, but what makes this problem a good fit for the sliding window approach? First, let's try looking at a few other possible approaches. Let's have one. Let's call it brute force. This is the one where we would iterate through all possible prices of all possible price differences, and then we would return the max. So for every day, we would look for the best day to sell. This approach is pretty straightforward, but it would be O of n squared in time complexity. It would be O of 1 in space, but the extra time complexity really doesn't make it a good solution for this problem. A sliding window allows us to allows us to solve the problem by iterating through it once, which would make it O of n in time and also O of 1 in space. And with this approach, there isn't really too much need for like some other algorithm. In order to find the best state, we would still need to iterate through the whole list, and the most efficient way to do that is O of n time and O of 1 space. Now, how will we implement a sliding window? Let's use the first example as our example. So let's say on the first, when we make the sliding window, we just have 10. Both the left and right boundaries, or both like the left and right boundaries are on this this date. And something I'd like to mention going into this is that the left edge of the window represents the purchase date, and the right edge represents the selling date. So we want to return the answer that's the highest difference between the left edge and the right edge. So what do we do when we have a sliding window of 10 and a prices of 10, 1, 5, 6, 7, 1? So we would we would see that the next digit is lower than the current left edge. And that tells us that there's no possible way that 10 can be where the purchase date is supposed to be. Because right in front of it, there's an even better purchase date, regardless of what the next the next prices may be. So once we have our window of 10 and we see 1 as the next date, we would move our window to 1. Next, we see 5 as the next day. We still want to iterate the selling date because we want to get the best possible selling date. And to do that, we would have to iterate through every single one and get the maximum. But 5 is not lower than 1, so we have no reason to move the purchase date forward. So we expand our window to 1 and 5. Next, we see 6. So 1 and 5 would become 1, 5, and 6. This increases our profit by 1. Next, we have 1, 5, and 6, which expands to 1, 5, 6, 7. Again, the next digit is larger than the current right, so we would track the maximum profit, but there's no reason to move the purchase date. We would only move the purchase date if we see a date that's lower than the current purchase date. finally, we see 1, 5, 6, 7. We would continue to move the right edge of the window to 1 because of course we want to iterate through the entire array, but the profit between 1 and 7 would still be kept as our maximum profit. So let's get started with the coding. Let's make our variables max profit is 0, and left and right are both 0. Then we want to iterate through the loop. While right is less than length of prices, we want to check if looking back at this, I want to get one possible behavior out of the way. And for that, let's use this example. What happens to, I guess, the left and right if, never mind. I think that's already been covered. Let's say we currently have our sliding window here, and we see our next option is even smaller than the current purchase date. At this point, there's no reason to continue holding on to our current purchase date, and instead we can just update it to this one. We already got the max from the difference between 2 and 7. Everything else that follows this purchase date of 1 is guaranteed to be better than having a purchase date of 2. So if we're at the point where we see our windows 2, 5, 6, 7, and we see a 1, our sliding window would become 1. So how does that look in code? We want to basically, our updating the right edge is a given. We want to update our right by 1. And then we want to update max profit. So max profit would be the max of itself and the distance between left and right. So prices left minus, no, prices right minus prices left. Then we would check if no, that isn't necessary to check that every time. Let's add it here. If prices at right is less than prices at left, then we want to set left to the right. Otherwise, we want to at least try to see if the max profit has been updated. This continues until right breaks through the end of the array, at which point we would return right. Now I want to take a look at how this compares to the test cases. Oh, I've made a... okay, so there was an issue with how I wrote this. Left let's set it left equals 0, right equals 0. Let's run that again. Oh, the list index is out of range. Okay. I see. So after I hit the loop where right becomes equal to the length of prices, um, there's no possible way it can continue to move forward. But it tries to do that in the next loop, which is causing an index out of range error. So let's set that to equals for now, and let's try that again. Of course. With the indexing, it's always going to be one less than the length of the array. So let's add the -1. Oh, okay. This is just one more issue. I didn't handle the edge case where there's only one date. Of course, in that situation, if right iterates at all, um, it would break. So if the length of prices equals 1, we return 0. And I believe that this flow should handle the rest of the use cases. But let's see. Okay, I think I need to dissect this more carefully. I think I've made a serious mistake somewhere here. Hmm. I think adding the equal sign was actually a mistake. I think that might have extended the amount of times right can move forward when that isn't what we need. And with that said, I don't think this case should break anymore. Oh, there's another issue waiting to happen right there. Um, it should return max profit, not right. Now let's give this a try. Okay, so it did pass the two cases. It seems like we didn't need to explicitly code our edge case. As long as the loop breaks as soon as right equals 0 and there's no index greater than that, then we can proceed. Let's submit this and see if it works. Okay, so we did successfully complete this problem. Now, just to reiterate, this was an O of n time and O of 1 space. And the way that we used both 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 edges in this case can be pretty comparable with a two-pointer approach. So I don't think it would be an exaggeration or a misstep to also consider this a two-pointer type of approach as well. But with that said, I think that's it for today's video, and I hope to see you all in the next one. Thank you very much.